Okay, excellent. Well, welcome everybody. I see we have some folks coming in, so we might wait a couple of minutes to get started, but welcome everybody who is joining us this morning. All right. Well, we are going to get started. So welcome everybody, and thanks for taking the time to join us this morning on our second Fireside chat. Today, we're going to be discussing the reliability of publicly deployed IoT assets. My name is Walter Thorn. I'm a Senior Vice President of Product and Strategy, and I'm joined here by my colleague, Daniel Engelman, who is our VP of Reliability here at ChargerHelp. Daniel, do you want to start and introduce yourself?
Sure. My name is Daniel Engelman. I'm happy to be here today. I'm a VP of Reliability at ChargerHelp, and my role is to oversee our reliability as a service product, including the service delivery. And that includes overseeing our dispatch team and making sure that all of our services that we're providing in the field are being adhered to.
Great. And I'm Walter Thorn. I'm our Senior Vice President of Product and Strategy. I lead a few different teams here at ChargerHelp, work with Daniel on the reliability delivery side, also our product management team on our Empower technology platform that we've built for managing charging infrastructure reliability and maintenance. I've been with ChargerHelp for almost 2 years now in a full-time capacity. I was working with ChargerHelp as a consultant prior to that and have known Camille and the ChargerHelp team since the summer of 2020. It's kind of amazing to see the evolution of both the business and the growth of ChargerHelp, but then also the industry overall. When Camille started the company and as I was getting to know ChargerHelp, ChargerHelp understood and believed strongly that reliability of publicly deployed IoT assets and of charging equipment specifically was a huge issue that needed to be addressed. But it really, in the last 6 months, has come around to become a front and center discussion of, the overall transition to electrified transportation. And so it's really exciting to be where we are, to have kind of a front row seat to charger reliability. Literally, technicians every day on the ground, interacting with these assets, doing service work, maintaining them, but also just understanding that we have a long ways to go. And so we're going to talk about kind of some of those learnings, what we're observing in the field, how we think about other industries and what we can learn and bring to the EV charging ecosystem in our discussion today. And we do have, for those of you that are joining us on Zoom, we do have a Q&A function. So please feel free to put questions in. If you're joining us on LinkedIn Live, I think we have folks from our team that are hopefully monitoring that as well. So feel free to put questions wherever you can, and we'll do our best to address them. I guess starting question for you, Dan. You talk about kind of connected devices and have a background from prior roles in maintaining IoT devices, but how do you think about an IoT device, and what even is an IoT device?
Sure. Well, the definition, so an IoT stands for Internet of Things. As more and more devices became connected devices, that term was coined. So, initially we had computers and phones that were connected, but then now everything from our fridge to a Fitbit to a vehicle to a parking meter and an electric vehicle charging station is a connected device. And so, I think that term IoT is going to, kind of fall by the wayside, similar to, how the term smartphone is starting to die out. Now it's just a phone. These are just going to be devices, and everything will be connected. But the result of that is that we have much more visibility and eyes and data on the devices that are publicly deployed. So in a previous role, I worked on a program called Link NYC, which was a public-private partnership with the city of New York to replace all of the payphones in New York City's with links, which are kind of like the ultimate IoT device. It's a kiosk that broadcasts Wi-Fi to the citizens of New York City, and it also has a tablet on it that you can place phone calls, and it provides city services. And then there's 2 digital displays on the device that play advertisements, which funds the program. But that program was developed with connectivity in mind, not just for addressing issues around broadband and broadband equity, but also thinking about the multitude of devices that would be coming online in the urban landscape that would require connectivity. And at the time, the 5G network was just beginning to be built out, and additional options for connectivity were needed for all of the devices coming online. So that's sort of how I think about IoT devices, and specifically in the public realm and the urban landscape.
Yeah. And I think that experience with Link is super interesting. I'm curious, obviously there's a lot of connections that those devices, those Link devices, are supporting to other assets, right? Whether it's, other folks connecting via 5G or using the Wi-Fi, or even, connecting to services via the tablet that's embedded in them. But my understanding is that there was also connections back to your team and the folks operating them. And so that was another facet of why, those devices as connected kind of IoT, publicly deployed IoT assets was also interesting. Can you tell us more about kind of those kind of backward connections and how you leverage those, or how those played into how you thought about reliability and maintenance and operations?
Sure. So we had about 2,000 of those devices deployed across New York City, and we did have physical hands on those devices to maintain them and clean them, but most of the maintenance was done remotely. So the device itself had a maintenance board in it that had connectivity to each of the individual components in the structure, and we had telemetry that was gathered and sent back to our NOC so that we had visibility on the status of each of those individual components. And we had some remote capabilities, and we built more sophisticated capabilities as time went on. Initially we had the ability to reboot remotely the structure as a whole, and eventually we built in the capability to reboot individual components, which helped resolve the majority of the issues that we would see in the field. So that gave us the visibility that we needed, in order to maintain some of those remotely.
Very cool. And was all of those as you think about the feature evolution, especially from a reliability standpoint, were those all software features, or were there any that also required hardware upgrades or changes to kind of the bill of materials of that device that was deployed out into the field?
Most of that was contemplated at the original hardware design of the unit. So the upgrades, that were built in were mostly software upgrades. But the initial design, contemplated making sure that we had connectivity at the individual component level. And I think that is unique for publicly deployed IoT devices. We work in the realm of electric vehicle charging stations, and we don't always have that capability. I think this is one of the the myths around EV charging and maintaining EV charging infrastructure in the field, is that we have that sort of telemetry, and in many cases we actually don't. And a lot of the failure that is occurring that prevents a driver from being able to charge successfully are things that we can't always monitor remotely. For example, the actual connector has multiple pins. Those pins break. There are screens on EV charging stations that get vandalized, and a lot of the charging station manufacturers are not yet providing the telemetry that's necessary in order to be aware of those types of failures remotely. Mm-hmm. And so augmenting that with a workforce and staff that's able to give us those eyes in the field is necessary.
Yeah, for sure. I'm curious, just to keep pulling on kind of the thread around the analogy with intersection and the Link NYC devices. Can you tell us more just around kind of the nature of that deployment, right? So they're obviously in an urban area in New York City, but like there are other things that we know make the servicing and the maintenance of IoT assets challenging. Like EV charging stations can be far apart, and so there can be a lot of just travel time and effort to get to these stations. What was the kind of density of the Link network, and how did that have implications for the way that you set up kind of service plans and operationalize the maintenance of that equipment?
Yeah. We were not challenged by long distances the way we are with EV charging. As you mentioned, the density of that deployment was high. So intersection, we had assets in about 15 markets across the United States. Link NYC was one of those deployments. We also had digital advertising networks in other markets too. But the same was true for all of them, which was that, they were in dense urban environments. So, either on the streets of New York or in transit environments like digital bus shelters or on train platforms. And so our service technicians were able to, get to them relatively easily. And we were able to create maintenance routes for them where they could hit, maybe a dozen assets in a single day. And in the EV charging landscape, that's very different. Our network is nationwide, and sometimes there's clusters of stations, but for the most part, our technicians are spending a lot of time traveling in order to get to those locations. So the need to have remote diagnostics, remote telemetry, and remote monitoring is significantly more impactful for EV charging. So getting that level of visibility and working with our OEM partners, it would go a long way in terms of impacting the reliability of the EV charging network.
Yeah. And I guess just bringing it home, I mean, you mentioned just the need for telemetry and remote monitoring for the Link NYC assets. How often did you know what the problem was when you did need to send a technician out to do something in the field versus how much diagnostic you were needing to do on the ground?
I mean, I can't recall, a specific metric for you, but anecdotally, it was, a majority of the issues we were able to resolve remotely, within categories, mostly, um, intermittent issues or things that could be resolved via reboot. We would do that remotely. Vandalism in urban environments is a reality. So we would have regular schedules of cleaning for graffiti and etching, and remediating paint damage and things like that. We also had um, uh, many instances of severe vandalism with broken glass. So obviously things like that cannot be remediated remotely, but we would become aware of them when it did happen. So we had remote sensors that had the ability to notify us, via an accelerometer if the unit was hit. That wasn't always enabled, but we did have the ability to turn that on if we needed to. So our SLAs with our partners, who are usually transit authorities or municipalities, for make safes were not days, they were hours. So if there was broken glass or a dangerous situation, we had to get out there quickly and we had to know about it quickly. So in that regard, while we couldn't remediate the issue remotely, we could become aware of it so that we could dispatch quickly and at least make safe the situation.
Yeah.
Yeah.
Awesome. So I guess transitioning back to, EV charging, you mentioned that in most cases, the assets that we're working on don't have maintenance boards. So we don't necessarily have the ability to control every component within the charger. And we, in most cases, also don't have the level of telemetry that it sounds like you had in that case. What are some of the other differences that you've observed with EV charging as a publicly deployed IoT asset? And I guess one that comes to mind for me is kind of how just diverse the different kind of use cases are. So, we have public and private charging, we have, workplace and residential, and then we also have, a growing fleet of EVs and different types of EVs and manufacturers and models that all of these charging stations need to be kind of interoperable with. And that, seems like it has been or in my experience, it has been another kind of source of challenge for our industry. But I'm curious what else you've seen as you've transitioned into your role at ChargerHelp, working on the reliability of EV charging equipment.
Yeah, good question. I mean, the variability is exponentially more complex, right? Like you said, we have multiple different OEMs, manufacturers that build EV charging stations. We have multiple vehicle types that the assumption is that there wouldn't necessarily be interoperability issues, but there are. Certain vehicles do not charge on certain charging types, and I'm not sure that that's something that is publicly well known, but in our experience we've seen that. So in developing how we are going to sort of address some of these issues around maintenance, there's just so many more variables to consider than in my previous role, where we built or bought a device and deployed it, and it interacted in some cases with public users. The Link NYC had a tablet and was connecting users to Wi-Fi, but we didn't experience the same level of variability and interoperability challenges that we have to face with EV charging. So in that regard, the need for, at least at this stage that the industry is in, the need for having, human interaction and technicians on site troubleshooting these issues is very real and very necessary. Whereas, we could get away with relying, heavily on remote telemetry in my previous role.
Yeah, that's a good call out. How, I mean, and we're working with our customers on designing, reliability strategies. Maybe could you talk to some of the different ways that we're doing that and some of the things that we're doing, preventative maintenance being one. I'm curious, like what your preventative maintenance cadence was previously, and then, where are you and the team kind of landing on best practices for things like preventative maintenance for EV charging equipment?
Yeah. Preventative maintenance and regular inspections are the two, primary strategies that we're employing right now. Because we don't always have that telemetry, we have to have our own eyes and hands on those assets. So, regular inspections, at a cadence of, quarterly or monthly, we find is good. And preventative maintenance is sort of a step up from that, where we actually follow the manufacturer's recommendations for inspecting each individual level, component level, and conducting preventative maintenance. And it's like a tune-up for your car, but for the charger and the device itself. Because these devices are out in, they're in the elements, they're being used by the public, and they need maintenance on a regular basis that, otherwise, if there's a problem, we would send a technician out to address that problem. But if there's no problem, we want to make sure that those issues don't occur, and that's where preventative maintenance comes in.
Yeah, no, I love it. And, you talked when you were describing kind of like IoT devices or connected devices. I mean, you said, we no longer call smartphones, we just call them phones. But, smartphones are also kind of connected devices, right? They have, connections in both directions. We regularly get updates over the air. But one of the things that as I've thought about kind of different analogies that we can learn from in the EV charging space as well, like smartphones have a much shorter life cycle than EV charging equipment does. And, maybe the average lifespan, I don't know the exact number of a smartphone, is maybe two years. EV chargers can be out there for 5 to maybe even 10, which, I think has a lot more implications for how we think about, future proofing. You'd mentioned that a lot of the improvements that you were able to make on the link stations were, software upgrades to improve controls and telemetry. But, if you don't have the right hardware in there to support them when you get that station installed, obviously the ability to make those changes gets more challenging. So I just think that's an interesting thing for us to consider is, like, how do we design for future reliability? And maybe, on that note, are there specific pieces of telemetry or information that you or your team would want, if you had a wish list for OEMs in terms of things that you would love to have visibility into that would improve, ChargerHelp's and your team's ability to, better manage reliability of these charging equipment?
Yeah, I think there's probably two categories of that. The first is, just binary up-down status at the component level, right? So like most devices, the initial level of troubleshooting leads us to, usually just replacement of a component, right? If there's, a screen that's broken, for example, maybe we'll send that screen back to the manufacturer for an RMA, but we're not troubleshooting the issue on that specific screen. So if we knew the up-down status of individual level components, that would be extremely beneficial, because we could dispatch a technician, with that component in hand. That would reduce our, number of truck rolls. So, oftentimes we'll be notified that a charging station isn't working, and we'll have to send a technician to diagnose the problem. But they won't necessarily have all of the parts, on hand that are necessary to remediate their problem. So if we could combine those two trips into a single trip, that would be really beneficial. So I think the up-down status of individual components would be really helpful. And then the second category are things that would give us the ability to conduct remote troubleshooting. Diagnostics or information that would help us diagnose remotely. So, power level output of chargers, or logging of payment systems, things that would give us visibility into potentially troubleshooting remotely would be super helpful.
Yeah, makes sense. I did see that there were a couple of questions that came in through Q&A. First question was around difference in reliability of chargers for multifamily housing versus public charging. How do we think about kind of the difference in reliability there? Do you want to
I was going to see if you wanted to take one.
Sure, I'll take that. I mean, I think, there are certain things that may improve reliability for multifamily. It may be less accessible to the public, which means that there's potentially less risk of vandalism. Potentially it's used by a regular set of drivers who are more incentivized to help take care of it. So things like rehanging the cables, making sure the connector is not left on the ground, protecting it from incidental damage. Potentially in a multifamily setting, the chargers might be indoors, and so they aren't going to get the exposure to the weather elements, rain, solar. Although, in many cases we see multifamily housing chargers outdoors as well. So yeah, potentially less exposed to potential harm. I think likely going to have similar interoperability challenges to what we see with public chargers in terms of the way that they interact with the consumer vehicle fleet. But yeah, likely better chance at higher reliability in that case. How long does it on average take, is the second question, to repair an EV charger? And how are we maintaining quality control? I'm happy to take that as well. I think it really depends on the type of activity. For a level 2 charger, I would say it's, between an hour to 2 hours, just because the scope of what you can do on a level 2 is generally less than on a DC fast charger. On DC fast charger, much harder to answer, just because in some cases it's relatively simple component swap out, but in other cases, like Daniel said, we don't always have visibility into what the problem is. And so, if you include all of the time that's required to diagnose an issue, then there are then the overall time to complete that repair could take longer. In terms of maintaining quality control, a few different parts of that. I mean, so on the proactive side of quality control, all of our technicians go through extensive training, both training that we've developed in-house for that EVSE technician role here at ChargerHelp, and then also our technicians undergo training provided by the by manufacturers. And so they're trained and kind of certified to work on specific equipment, and have that training. We also have a mobile app that we use that guides them through the work. So when they're on site doing the work, we provide guidance, and that helps with quality control. And then lastly, as part of the workflows that we serve them through the app, we have kind of quality control steps. So we have them take photos of the work that they've done. We have them complete test charges, which confirm that the charger is kind of operating in the intended state. And the combination of those different things allows us to ensure kind of high quality of service by our technicians that are working on the chargers. A couple more questions come in. Graffiti, is there a certain cleaning solution preferred by the manufacturer? I think it does depend on the manufacturer. I don't know, Daniel, if there was something specific you've used previously. I think the one note that I would add is that in some cases the chargers are vinyl wrapped, and so it really does depend on whether it's a vinyl coating, whether it's painted, the actual cabinet. But yeah, any thoughts on kind of best practices around cleaning and graffiti generally?
Yeah, I mean, I think you nailed it. It's it would depend on the type of coating and the type of paint. So I think we would want to get that recommendation from the manufacturer. There are solutions that are universal, that are pretty safe to use for multiple different units. I don't have that off the top of my head, but yeah, generally we would want to take the recommendation from the manufacturer.
Cool. A couple other
Walter,
yeah, go ahead.
Maybe one question I have for you, maybe thinking about some of the parallels that I was talking about based on previous experience. Are there other industries or experiences that you have that you think we can draw from, at this particular stage in the rollout of the EV charging stations? I mean, it's a very nascent industry right now, and I'm just wondering if you have any thoughts about that.
Yeah, there's a couple that I think about. I mean, my background is in the automotive space, so I started my career at Honda, and that example, I think about kind of some of the electronic devices that are increasingly part of automobiles, but especially in the past, like things like infotainment devices were kind of notoriously difficult to keep reliability for, just because the design cycle and the life cycle of vehicles, they're typically on for major models, it's like a 5 to 7 year cycle, and takes many years to go through R&D, and then you freeze the designs, and then you get into production. And by the time you're actually rolling vehicles off the lot, sometimes the software that you've put like in the infotainment system is out of date. And Bluetooth connectivity was notoriously one of the hardest things to maintain, because the Bluetooth spec was always evolving. And so by the time you had a car off the line into the driver's hands, the Bluetooth spec on their phone didn't necessarily work with the Bluetooth that was embedded in the infotainment system. And so I think that obviously has lessons around how we think about being able to push over the air updates, right? So remember the days when if you wanted to update the maps in your infotainment system again on your car, you had to like buy a set of DVDs or CDs from the manufacturer and like load them in manually. Now we can do things over the air, and so having kind of software defined features and being able to make those upgrades over the air is really important, and I think something that will continue to need to be able to leverage with EV charging equipment. That being said, in the equipment that's installed today, there is a lot of variability in terms of how over-the-air updates can occur, and in some cases you do actually need a technician on site that like plugs into the station and updates firmware or makes software configuration changes in person. And so truly making that over the air, I think will continue to improve charger reliability. The other analog that I think about is kind of the evolution of telecom, and in particular, what happened from the early days of wireless to where we are today, right? So early days of wireless, limited number of users, very narrow bandwidth, I would say relatively poor user experience in terms of dropped calls and roaming and just the overall way that you interacted with the wireless network, to today, relatively very extensive coverage, seamless handoffs between carriers, roaming, all of that works really well. And so the question is, what does it take for us to get to kind of that type of user experience in EV charging? I think some of that is, was driven in the telecom space through consolidation, which, we likely expect, and we're seeing some of that happening in EV charging already, as well as, I think, extensive adoption of standards. And so I think standards are the one where we still have a lot of room for improvement in EV charging space. One of the things that we are working on the product side at ChargerHelp is, how do we better understand OCPP data? So OCPP is the protocol for charger to basically cloud control system communication. And so improving our ability to kind of interpolate or compare what OCPP is saying to what our technicians are saying in the field allows us to have a more holistic and better understanding of charging equipment. But OCPP is really just a communication protocol. It doesn't necessarily specify what should be communicated. So it kind of says how you should communicate. But there is standards work that is ongoing around also improving what should be communicated. So the joint office between the DOE and DOT at the federal level put together the Charging Experience Consortium, which ChargerHelp and myself have been participating in. And one of the things that group is doing is coming up with a set of common error codes that we're hoping that the industry more broadly will be implementing, so that we have better standards around how we can understand what's going on with chargers. And then obviously there are other standards like the charging standards, whether it's the North America standard for the CCS type 1 standard, or the North America charging standard, or the Tesla connector. So all of those standards and standards adoption and standard compliance will also make big improvements to, I think, to overall charging reliability. But so there are things that are similar to these analogies, but on the other hand, there are things that are unique about EV charging. And so I think we'll continue to see our own kind of unique set of problems that we as a collective charging industry will need to come up with unique solutions to. So can't completely look to these other examples for the solutions to charging reliability.
Yeah, it's a challenging and exciting time in our industry.
Indeed.
Maybe one of the questions that came in, I think maybe each of us could try and answer. Why don't you go first? What is the most interesting reliability issue that you've seen?
Oh, the most interesting reliability issue. The one that comes to mind initially is actually around data and connectivity. So a lot of EV chargers are connected to the cloud via a cellular modem. So they have a SIM card similar to your phone, and they used that cellular connection to connect to the backend software that does all the controls and monitoring. And they use generally public networks. So they're on the same kind of, AT&T, T-Mobile, Verizon networks that many of our cell phones are on. We saw chargers that were having kind of intermittent communication issues throughout the day. And when we looked at the data longitudinally, we saw that there was this cyclical pattern of them being very well connected at night. But as 9 o'clock in the morning rolled around, the connection issues started to happen, and then that kind of continued into the evening. And what we realized when we looked at the map was that the chargers were actually located next to a hospital. And so during the day, a combination of a lot of people came to the hospital, and then also they were running a lot of their equipment. And so, the hypothesis was that the combination of kind of overall load or people trying to connect to the network, plus potentially interference from some of their equipment, was causing the connectivity to fail. And so what we were able to do was actually switch to a different carrier, which had more bandwidth and better connections and stabilize the connections for those chargers. But similar to somebody who's at a big sporting event, where you can have 5 bars of service but not be able to send a text message. Charging stations can kind of fall victim to the same thing, where if they're using that public cellular infrastructure, they're competing for a connection with all the cell phones and everybody else. And so that was just an interesting one, because oftentimes when we went, we couldn't see immediately why it wasn't connecting. But yeah, when we looked at kind of the time of day and the data over time, we could see that pattern that allowed us to figure out what was going on. What about yourself?
Interesting.
What's been something that you've seen? That's
Well,
been interesting?
yeah, I mean, so I joined ChargerHelp in July. So my sample set is somewhat limited. So I guess I'll give a more holistic answer around, in the absence of, the telemetry that we've been talking about, we've been gathering data from technician visits. And so that's been an incredibly interesting exercise to see, what kind of issues we're seeing across different manufacturers, different geographies, and different charging use cases. I guess I can give an example from Link NYC, where we were seeing issues on the tablet, and failures on that specific component, but the failure would vary from device to device. So every time we would try and troubleshoot, a specific incident, the conclusion was different. And ultimately, we had determined that a specific manufacturing output had a faulty gasket that was allowing water ingress to occur, and the water was dripping specifically onto the board of the tablet. And I guess the timing of when that happened and what was being executed at the time that happened was variable every single time. So it was only when that faulty gasket became apparent that we were able to then go back and draw that conclusion. So yeah, that's an interesting use case or lesson in troubleshooting and kind of going down that rabbit hole, and the solution might not become apparent until the answer just kind of comes from elsewhere.
Yeah, for sure. And question on that, when you realized that it was a faulty gasket, did you have a way to trace back to what which of the units that had been installed might be affected? Like, was it all the way down to like a specific lot of manufactured devices had that faulty gasket, or like once you had kind of identified that root cause, what were the next steps that you guys took?
So we were able to, because we had, the manufacturer had that specific level of bill of materials and what component they were using. So when they switched to that, they were able to identify the serial numbers of the devices that had that gasket, so we could use that to trace specifically which ones had that problem. Remediating it was significantly challenging because you're talking about, it's not, you can't recall those devices, right? You have to remediate them in the field. And so you're talking about doing a retrofit, which is challenging in coordinating that type of change. It involves basically disassembling the structure in public while it's in use, and I think it was hundreds that probably it needed to happen. So it was a major campaign to remediate that, and at the same time it was urgent because there was water getting out on the internal components. So yeah,
for sure.
Not the root cause conclusion that you would hope for.
No, certainly not something that takes that much to resolve. Another question that has come in is just around kind of pricing for operations and maintenance. So obviously there are a handful of different models out there, and a couple of different models that we support here at ChargerHelp. But specifically, a question is, what do we think about fixed labor pricing for operations and maintenance? So maybe curious your thoughts, and then I have a couple myself.
Yeah, I mean, that's basically kind of gets to the heart of our reliability as a service product, right? Where we are, the product we are delivering is the reliability of the charger, as opposed to hourly operations and maintenance or specific resolution of specific faults. So if our customers that engage in this product, they have a set number of chargers, and they have chosen an SLA, a service level agreement, in terms of our response time, and then we set a price based on that. And whether the charger has 1 issue or 100 issues, that customer is paying the same price. And I think ultimately that's the place that we want to get to. We want to be able to rely on the data that we have in order to set that pricing effectively, both for our own cost and what makes sense for our customers. So that's and that's in line with other industries too. Like, as a customer, you don't want to be really thinking about how many failures is this device going to have, and am I going to be paying for it more if it has more failures. You want to just pay a price and use and know that you're getting reliability based on that. So that's on the pricing side. Now on the cost side, then it's on us to be able to use the data that we have to price it accordingly to make sure that it's sustainable.
Yeah, I love that. I think the predictability piece is really important to our customers, and then both what you said around making sure that we're pricing it properly, but also once somebody has bought it, that price is set. And so I think there's also really good incentive alignment on our side. It's in our best interest to make sure that the charger is operating reliably, because every truck roll costs us incrementally. And so we want to use preventative maintenance, data analytics, remote diagnostics, remote resolutions to the extent that we can, because the more reliable the equipment, the better economics are for us as well. So I think there's really good incentive alignment there. I guess the last question, probably one that we can, or maybe there's one more that came in. How do we scale reliability in techs with the projected amount of chargers that plan to be installed? 1.2 million public chargers by 2030. Happy to start with that one. I mean, I think like the biggest thing that we're doing is continuing to invest in training and the certification work. So we are working with the Society of Automotive Engineers. I don't know if they still call themselves that, but SAE, to develop a credentialing standard for EVSE technician, and that is one that we've been instrumental in helping develop, and we will continue to train toward that standard. So we are excited about the opportunities that EV charging is creating, both from a data analytics standpoint, but also very importantly from how do we service and maintain the equipment in the field. And so that that public kind of testing standard will ensure kind of, I think, equity and access to this new industry. And we're really excited to be, a core part of helping create those opportunities. Last question, I guess, for you, Daniel, before we close here this afternoon, or I guess this morning Pacific time, this afternoon East Coast time. Do you think we will ever solve all of the reliability issues that we've seen for EV charging?
Well, yes, of course. I guess I'll answer that in terms of the reliability issue as a whole that we have around EV charging now, and I think that happens, via a lot of the things that we've been talking about today. I think scaling happens through the minimizing of variability, the ability to address field issues remotely, and by developing a workforce that's able to issue the issues remotely that can't be in the field that can't be addressed remotely. And so I think all those things will happen, and I think it will take time, similar to the analogy, Walter, that you gave us around what happened in the wireless industry and automotive industries. And I think that will happen, and we will get there, but I think it will take some time. I think for me, the question is the timeline of the deployment of the EV charging networks, and the reliability, how the speed of those two things will eventually meet, right? The deployment is accelerating right now faster than the improvement of reliability. That's why ChargerHelp was founded, and that's why we're doing what we're doing, so that we can try and increase the pace of the reliability of charging. And so yeah, I think that's what it's going to take. But I do think, yes, we will get there.
Cool. And I would tend to agree. Definitely optimistic that we will get there. I think, like you said, timing is important, and I think the big question for me is like, how long is it going to take us to get there? So the statistic I've heard is that we're potentially 20 years behind kind of where telecom is, from a evolution and life cycle standpoint. I really hope that it doesn't take us 20 years to get to the level of driver experience that we have grown to expect, and from the cellular standpoint. And I think, like you said, ChargerHelp exists to help us catch up on the reliability side. And I think specifically the way that we're approaching that, through use of data, through use of analytics, through use of skilling, not just to get people out in the field to resolve issues, but to also help with better data capture and more holistic data that we can then use to provide feedback back to the ecosystem to learn better, learn faster. I think hopefully helps, ChargerHelp can help the industry achieve that better outcome, in a shorter period of time. I think that's a really good maybe place for us to close today. Thank you for the time today, Daniel, and thank you for everybody who joined us online. Hope you enjoyed the conversation. We appreciate the questions, and we're here to support the industry. So if you ever have any more questions around charging reliability, please don't hesitate to reach out to our team. So with that, I will wish everybody a happy Monday, and we'll close for today. Thanks so much.
Thanks, Walter. This was fun. Thank you.
Yeah, bye.
Bye.